So we are continuing in 2.1 and we're looking at using mathematical models for applying linear equations. So let's read through this last problem that is in our packet. It says persons with a low sense of humor have higher levels of depression in response to negative life events than those with a high sense of humor. This can be modeled by this formula. So we are given this formula. And it says in this formula, so let's grab our highlighter. It says X represents the intensity of a negative life event. So we have an X in the formula right here. And that's what it represents. And then it says that we have D. And D is the output. And D is the average level of depression in response to that event. So D is here. If the low humor group averages a level of depression of 10 in response to a negative life event, what is the intensity of the event? So I have to know, where do I put in this D, this 10? Do I put it in for D? This is depression of 10, and D is the level of depression. Or do I put it in for X? So because it says depression of 10, I'm going to put it in for D. And the question that it's asking is, what is the intensity of that event? So it's looking for the intensity, which is what is represented by the X. So I'm going to put in, going to use my blank page at the end, and in place of D, I'm going to put 10 into the formula. And then I will put 10 over 9x plus 53 over 9. And then I'm going to solve for x. So I want to solve for x. And so in order to solve this for x, we have to do some algebra here. So I need to get x by itself, so move all the numbers to one side. 59 over 3 is a number. It is fraction form, but it is a number. So I need to move that to the other side. But wait, we learned a different technique. Remember? We want to clear the fractions. So instead of doing that and having to figure out a common denominator and all of that, instead we learned that, wait, I can clear the fractions. So how could I clear the fractions here? Well, I could multiply by the least common denominator, and the fraction here, they are the same denominator of 9. So I'll multiply everything by 9. So I'll multiply 10 by 9, I'll multiply 10 over 9, x by 9, and 53 over 9 by 9. And that is going to make this problem a lot easier to complete. So I'm going to have 9 times 10 on the left side. I'll have 9 times 10 over 9x here. And to finish up the right side, I'll have 9 times 53 over 9. Now what's going to happen here? I'll get 90, 9 times 10. Here, the 9's will divide out and I'll be left with 10x. And here also the 9's will divide out and I'll be left with 53. And now this is going to make it a lot easier because now I'm going to subtract 53 from both sides. So subtracting an integer as opposed to fractions. So 90 minus 53, that's going to leave me with 37 is equal to 10x. And then I'm going to divide both sides by 10 to get x by itself. And I'll get my answer for x. So either I'm going to say 37 over 10 if the MyLab Math wants it in fraction form, or I'm going to divide by 10 and put it in a decimal form and say 33.7. So the intensity of this event would be 3.7. Now let's look at one more question. Let's pull up the MyLab Math and look at one more question to practice more of these. So here is the MyMathLab, and here we have one of our application problems. Now this comes from 2.1. It's number 28 if you want to follow along in your MyLab Math. So it says the graph here shows the cost of inflation in some country. What cost 10,000 in 1975 would cost the amount shown in the graph in subsequent years. Below are two mathematical models for the data shown in the graph. In each formula, C represents the cost, and X represents the years after 1980, of which 10,000 of what cost 10,000 in 1975. Answer parts A through C. So whenever you see this, you have these little buttons here. You can hit this to expand it. You can also hit this to pull it up in a different window to look at it closer. So know that you have those buttons to use. So let's go to our whiteboard and let's work on this. So in part A, it says to use the graph to estimate the cost in 2000 to the nearest $10,000 of what costs 10,000 in 1975. So I'm going to expand the graph and I'm going to look at it. And so in 2000, here's 2000. Let's go up to the graph and we're going to try to read this dot that's here. So if I go over to the left, I see that that is the number 34, and that's 34,000. So I'm going to put in the MyLab Math 34,000. Then it says, we'll use Model 1 to determine the cost in 2000 of what cost 10,000 in 1975. So Model 1 is here. And so X, we are told in the problem, the value that you're going to put in for X is the costs. C represents the cost X years after 1980. So we have to remember that 2000 is 20 years away from 80. So that I'm going to put in 20 here. So I use Model 1 and I put in 20. And let's grab the calculator and compute this. So 945 times 20 times, or I'm sorry, not times, but plus 15,481. And so here I get my answer. I'm going to put that in to the MyLab Math. How much does this differ from your estimate in part A? Well, part A, I said, was 34,000. So the difference between the two is 381. Then it's use the Model 2 to determine the cost in 2000 of what cost 10,000 in 1975. So again, I have to now take Model 2, which is listed right there, and the X value, again, it would be 20 because it's the number of years since 1980. So now in this one, I will put in 20 in two places, put it into my calculator. So here's my calculator, and let's put that in. Now, when I hit negative in front of the 2, make sure to hit the negative sign that's to the right of the decimal place. If you hit the minus sign, it wants to subtract it from something and it won't recognize it. Caret symbol 2 on this one, so I'm going to type it just like I see in the problem. Hit enter, and now I get this number. And that looks incorrect to me, much different from here. So when I look back at this, I notice that it looks like I didn't hit the 2 here in this last part. So what I have to do is re-enter this. Now, instead of retyping all of this, we can hit the second key and the enter button, and it brings it all in your previous entry. So we're going to put that in, and here, this is much closer to what my answer should be. And then again, I would subtract it from my answer in part A to come up with the answer for part D. By how much does this differ? And that is how you would complete this type of problem in the MyLab Math.